we are studying transient response of DC RC circuits. So we can see a voltage source V is connected with resistor and capacitor RNC. At t is equal to 0, the switch is closed. So let our DC voltage be applied at t is equal to 0 by closing the switch SW in a series RC circuits. And the capacitor is initially uncharged. So you can apply a KVL and we will get resistive drop plus capacitive drop is equal to supply voltage. So Ri plus 1 upon C integration I dt is equal to V. We will differentiate it, differentiating both sides. So R I dt, R di dt plus 1 upon C I is equal to 0. So from this I can write di dt plus 1 upon RC into I is equal to 0. So this one is equation 1. So equation 1 is a homogeneous differential equation with only the complementary functions. The particular solutions for this above equation is 0. And solution of this type of differential equation is I is equal to C into e to the power minus t by RC. This one is equation number 2. But C is the arbitrary constant and we will find the value of C. And we know that in the circuit shown in figure, the switch SW is closed at t is equal to 0. Since the capacitor never allows sudden change in voltage, it will act as short circuit. So at t is equal to 0 plus means just after the switching. The current in the circuit at t is equal to 0 plus is equal to V by R, as the capacitor initially behaves as short circuit and it doesn't allow sudden change in voltage. So at t is equal to 0, I is equal to V by R. Now substituting these values in equation 2, What we get? We get V by R. So from equation 2, we get V by R is equal to C into e to the power 0 at t is equal to 0. So, and e to the power 0 is equal to 1. So, C is equal to V by R. Therefore, the current become I is equal to C into e to the power minus t by RC. So, this is equal to I is equal to V by R into e to the power minus t by RC. When switch is closed, the response decays with time. E to the power minus t by RC. So here tau is equal to RC. RC is equal to time constant. After 5 time constant, the curve reaches 99% of its final value. Voltage across the resistor. Voltage across resistor is VR. VR is equal to RI. So R into I means the expression of R. V by R into T to the power minus e to the power minus T by RC. So R cancelled and it is V into e to the power minus T by RC. Similarly, voltage across the capacitor. Now VC is equal to V into e to the power minus T by RC. So putting the value of C is equal to V in equation 2, we'll get this one. Therefore, VC is equal to V into 1 minus e to the power T by RC. And power in the resistor is a PR is equal to VR into I. And VR is equal to RI. So I am putting the value of I is equal to V by R, e to the power minus T by RC. Here our objective to find the power in the resistor, power in the capacitor. So V square by R e to the power minus twice T by RC. Now power in the capacitor PC is equal to VC into I. So expression of VC is equal to V into 1 minus e to the power T by RC, and I is V by R e to the power minus T by RC. So it's equal to V square by R, and you multiply 1 into e to the power minus T by RC minus e to the power twice T by RC. So that's all about the RC circuit, transient response of RC circuits. Thank you for watching.